Okay. So in this 9.2, we are doing what we call binomial expansion. And so I'm gonna write that at the top. It says expand. So this is called binomial expansion. You guys know what the word binomial means?
Two names. Two.
Two. It's like x plus y or 3x minus 4. It's a two-term polynomial. So it's a polynomial with just two terms in it. And we are going to expand it out. So what we're going to do is we're going to do 4 of these by hand. We're going to do x plus y to the first, x plus y squared to the third, and to the fourth by hand. And then we're going to see if we can find a pattern. I'm going to tell you there is going to be a pattern so that we can use a pattern from now on instead of just multiplying it out every time. Okay, if I have x plus y to the first, when I expand that out, that is just going to be x plus y. Everybody's cool with that? Okay, when I do x plus y squared, we've got to multiply x plus y times x plus y. And you actually need to FOIL that guy out. So multiply, multiply. When I end up doing this, I like to do like I like to kind of stack them row on top of row. It's not going to really matter right here, but it's going to make a difference later on. X times x is x squared, and then x times y is xy. And then my next row I do y times x. That's the same thing as xy. I don't care what order you write them in, but we want them to be consistent. So y times x. Yx is the same thing as xy. So I like to write it the same in both cases. And then y times y is y squared. I like to write them on top of each other just because it makes it easy to combine terms as we go. And it really maybe won't seem that big of a deal on that first one. But as we go on, you'll be like, oh, I think it makes sense to stack them up. So my answer here is that. I actually want that. All right, that's what I get when I do x plus y squared. Everybody good with that? Okay, now I'm going to do it to the third. So I need to take the answer we just got and multiply it by x plus y again, because now we're doing it to the third. So now I'm going to do x plus y times that x squared plus 2xy plus y squared. So let me make sure you've got lots of room. All right, so again, I'm going to distribute, I'm going to FOIL through. X times x squared is x to the third. 2xy times x is 2x squared y, and then x times y squared is xy squared. Is everybody doing okay so far? Okay, now I'll do the y's times everything. Y times x squared is x squared y. Y times 2xy is 2xy squared, and then y times y squared is y to the third. So I get x to the third plus 3x squared y plus 3xy squared plus y to the third. Okay, everybody good so far? Last set we're going to do is we're going to do this to the fourth. So now I'm going to take what I just got and multiply it by x plus y again. Okay. So we'll do x plus y times, and it's going to be that x to the third plus 3x squared y plus, oops, I gotta move down out of space. Plus 3xy squared plus y to the third.
Okay, so just.
Can't we just add? Add what?
3x.
Ooh, good question. This one has a square on the x and this one doesn't have a square on the x. So those are technically not like terms. Good question. All right, I want you to distribute, factor it through, and tell me what you get. And then I'm going to ask, do we see any patterns, any way to make it easier so we don't have to keep doing this every time they ask it? X to the 4. Oh, that's a lot. Are you guys all getting the same answer as I am? Make sure you're getting the same answer as I am. And then we're gonna find our patterns. Okay, we're gonna start with the pattern of our coefficients. Is everybody good with what I've done so far? Okay, we're gonna make something called Pascal's triangle. Is that something you've heard about before? Okay. It's a tool that helps us with our coefficients here. So notice in all of these, in my first x plus y to the first, I have a coefficient of 1 and I have a coefficient of 1. Okay, when I do x plus y squared, that's my pink one over here. I have a coefficient of 1, I have a coefficient of 2, I have a coefficient of 1. Okay, that's my x plus y squared. Now the green one was x plus y to the third. I have a coefficient of 1, I have a coefficient of 3, I have a coefficient of 3, and I have a coefficient of 1. And then the last one we just did, this one in black, is x to the fourth, or x plus y to the fourth, coefficient of 1, coefficient of 4, coefficient of 6, coefficient of 4, coefficient of 1. Okay, I hope I kind of see some brains turning a little bit. Let's just write a list, like rows of those coefficients, okay? So I'm gonna come over here and we're gonna use this empty space and we're gonna start with 1 and 1. That was our x plus y to the first power. Our coefficients for x plus y squared was 1, 2, 1. Our coefficients for x plus y to the third is 1, 3, 3, 1. And then our coefficients from x plus y to the fourth was 1, 4, 6, 4, 1. This is what we call Pascal's triangle. And my question to you is, what are patterns? What are things that we're seeing here? What do you notice here that we can use to build maybe the next row? Anyone notice anything? What's something you notice about these numbers, Ryan? They both start and end with 1. That's awesome. So they both start and end with 1. They will always start and end with 1. Okay, so if I were to do the next row, that means my next number, I would always start with that 1. Okay, and I would end with that 1. How would I go about finding like this term right here? How did I have this? How did I get the 3? How did I get the 4? 1 plus 4, very good. The number that you have comes from the 2 above it. So 1 plus 4 adds together to be that number. Same thing right here, 3 came from 2 plus 1. 6 came from 3 plus 3. Both 4s came from 1 plus 3. All of these came from the 2 above it. So in my next row, I would have 1 and then I would have a 5. What would that next number be? 10. What would the next number after that be? 9. We're missing one. Another 10, right? I have 4 plus 6 and I've got 6 plus 4. I got 2 10s. Then what comes next? 5. And then I end with 1. Very good. Now, if you want to make a little bit more sense of this, off to the side, you can write like this was our x plus y to the first. This was our x plus y squared. This is our x plus y to the third. If that's too messy for you, notice that whatever the second number is what power we raised it to. So the second number, that's what power we raised it to. So you can just kind of look at that line and know which one you're on. Okay. technically there is an even top row. If we did anything to the 0 power, if I did x plus y to the 0 power, that's just 1. So actually, this pyramid is really nice, and it does start and end with that 1 at the very, very, very top. And again, this one is our x plus y to the 4th, x plus y to the 5th. And this could keep going forever. Like I could keep making as many rows as I wanted to. That's enough for right now, but like we could keep adding and adding rows if we wanted to. Pascal's triangle goes on and on forever. The reason we did this is because the next problem says, if so, or so, what is x plus y to the 5th? Instead of taking what we just did a minute ago and multiplying by x plus y again, which I think would be really annoying, we can just look at our line of our Pascal's triangle, and my coefficients are all going to be these numbers right here. So when I go to do this problem next, I'm going to start by just setting it up 1, 5, 10, 10, 5, and 1. Do you see how I took all of the coefficients that were in my triangle? I'm listing them out because I know I'm going to need those. And so you can go ahead and do that too on your paper if you want, because we're going to have to list those out. What comes next is what the x and the y are. So we'll discuss what pattern that is once you have your coefficients down. Okay, now looking at the ones above, what happens to my x as we go through the problem? My x does what as you go from term to term, going from left to right? And getting smaller, right? It started x to the 4th, then it went x to the 3rd, then x squared. Same thing in like the very beginning, it was x squared and then it was just 1x. So the x is going to decrease as we go across the page. It's going to start at whatever exponent is given to us. So 5 is the highest exponent we can be. And as we go across the page, we're going to go down an exponent each time. Notice that there's none in that last box. Technically, that's x to the 0. And what is x to the 0? 1. So that doesn't matter. So I don't like to write that x to the 0 because if I lose my 0, I get confused. I like to just know that there's one empty spot with no x's, but technically it still works because I go down to x to the 0 power. Okay, using that same thought process, what happens to my y's as we go across the page? It gets bigger. Good. So y is going to increase. Now, just like we had one term with no x, we were going to have one term with no y. So the first one would technically be our y to the 0, which again, if that helps you make sure that there's a y everywhere, do it. However, if you're going to mess up because the 0 is going to confuse you, then I don't want you to do that. The y to the 1st starts on the next one, and then y squared, and then y to the 3rd, then y to the 4th, and then y to the 5th. One way to check your work as we do this, any given term, the exponent should add to the exponent that was in the original problem. So they told us we're doing x plus y to the 5th. If I go to any one of these terms, the exponent should add to be 5. So if I do 4 and 1, does that add to be 5? What about 2 and 3? Does that add to be 5? Even just 5 by itself, is that 5? Yes, so if you want to check your work, your exponent should add to be that total exponent right there. Okay. I'm technically done here. I may rewrite this just so I don't have lines underneath it, so it looks a little bit neater, looks a little bit more organized. And I don't need the ones there, so I can write x to the 5th plus 5, x to the 4th, y, plus 10, x to the 3rd, y squared, plus 10, x squared, y to the 3rd, plus 5x, y to the 4th, plus y to the 5th. If you like the answer above with the lines and the ones to the 1st power, you're good to do that. But I just kind of cleaned it up a little bit. I organized it just a little bit better. Okay. On this one, we didn't have to do a lot of work because we just had x and y's. However, the next two, do you notice that we've got coefficients with our x and y's? Instead of just carrying down that like y to the 3rd, we're going to have to actually do that second term to the 3rd power. So let's set up that number 2. Let's see if we can do that one together. And then I'll show you how that looks when we have numbers and positives and negatives involved. Okay. Can you find your coefficients first? Go find your coefficients. When I list my coefficients out, which numbers am I going to use? 1, 4, 6, 4, 1. Very good. So again, I like to kind of give it a little bit of a pattern. 1, 4, 6, 4, 1. I like to give myself a little bit of space. Now, remind me, what's the X doing as we go across the paper? Going down, it's decreasing. So I'm gonna start at what exponent?
X4.
X to the 4, good, because that's what was given to us. And we're gonna go down as we go across the page. Since it's just an X by itself, you don't necessarily need parentheses around it. We can just keep it as X to the 4th, X to the 3rd, et cetera, et cetera. Now my Y, as we go across the page, what's gonna happen there? We're gonna increase, good. And I do actually want parentheses on this one because it's not just Y, it's -2Y. So I'm gonna skip the first line, and on the second line, I'm gonna go -2Y to the first, -2Y squared, -2Y to the third, -2Y to the fourth. Notice on all of those, I did my exponent outside of the parentheses. -2Y is in parentheses, 1 is on the outside, 2 is on the outside, 4 is on the outside. Okay, now when I go to simplify, we're gonna actually have to do a little bit of work. The first one, 1y to the, or 1x to the 4th, there's no work there, so I'm good to just write x to the 4th. I'm good to just bring that guy down. On the next term though, I've got 4, I've got x to the 3rd, and I've got -2y to the 1st. Anything to the 1st is just itself, so it's like -2 and y. So I've got 4 times x to the 3rd times -2 times y. Now, if we just wrote it like that, it'd be really ugly, so we're gonna combine our terms. I'm gonna combine 4 and times that by -2. So what's 4 times -2? -8, and then we'll throw our x and our y at the end. So that second term is -8 x to the 3rd y. Okay. The next term, I've got 6, I've got x squared, and then I have to do -2y squared. That means I have to square both the -2 and the y. What's -2 squared? 4. What's y squared? Just y squared, right? And so I'm gonna do 6 times 4 and get 24. Is that gonna be a positive or a -24? Positive. X squared y squared. Okay. The next one, I still have my 4, I have my x, but I have to do -2 to the 3rd and y to the 3rd. What's -2 to the 3rd? -8. And then y to the 3rd is just y to the 3rd. And so here I'll multiply 4 and -8. Is that going to be a positive or negative? Negative. And then finally, we're gonna fourth or raise to the 4th power that -2. So we'll do plus, is that 16 y to the 4th? Is that what 2 to the 4th is? So I'd argue this isn't that hard. There's just kind of a lot of steps here. Okay, we doing okay with this? Do you think you can try the next one on your own? The one underneath it is just like it. It's actually even a little bit shorter because it's just to the 3rd. Try that one on your own. I've got kind of my breakdown up on the board right now where I did my coefficients, I did my x's, I did my y's. Now I'm gonna actually do the exponents on them. All right, so I've got my answer for B on the board. Double check, see if you can do it on your own. Anybody questions yet? Okay, I've just got one more skill I want to teach you. So when you're done with this, turn your paper over. We're gonna do 3A and B. Okay. We're not gonna do the bottom of the page, probably ever, but we're gonna do 3A and B. This time, do you see how my exponents are so much bigger to the 10th and to the 7th? Those are numbers that we don't even have on our Pascal's triangle, so that would be a lot of work to keep building our Pascal's triangle down 2 to 5 more levels to get those coefficients and then go from there. So I have a bit of a shortcut, okay? We're gonna do our NCR to find our coefficient. Do you remember NCR from the other day? It's a button in your calculator. When we did this in probability, or like if I was like, okay, if I have a class of 20 kids and I want to pick, I don't know, 3 people as, I don't know, class leaders. I don't know, like kindergarten. Those 3 people, it doesn't matter what order they're picked in because they're just student leaders, they're just class leaders. It's like no one has a tier or a different position. The total number of kids is what would go in my N, and then how many of them I wanted to do the job would go in R. In this case, we're gonna put the exponent, like the total exponent is gonna be our N, and then R is going to either be the X or the Y exponent of whatever term they want of us. So it will be exponent of whatever the nth term is. And maybe to differentiate, I'll say total exponent for N, exponent of the nth term is what we're gonna do for R. Okay.
Wait, it's 10R.
10 is N. We actually don't know what R is right now. You're gonna be very tempted to make R just the 4th term. I think a lot of us are gonna be like, oh, well, we're gonna make R that 4. Well, it's not the exponent of the 4th term. So let's go figure out what the 4th term might be, and that will tell us what our exponent is, okay? So just, I keep doing these like little dashes, whatever makes you happy, you can do. If you hate these like little dashes, don't do them. That to me though gives me like 4 spots, and I care about this 4th spot. So I'm kind of mentally thinking, what do I need to do to get to that 4th spot? Okay. And so I'm thinking about my X's and my Y's. As I go across the page, what's my X doing? It's decreasing, right? So it starts at X to the 10th, and then what does it go to? And then, good. What about my Y term? What's it doing as we go across the page? Increasing. So there's no Y's, and then Y to the 1st, and then Y to the 2nd, and then Y to the 3rd. Okay. R is either 7 or 3. It is either 7 or 3. It does not matter which one you pick, you'll get the same answer either way, and I'll actually do it in the calculator to show you, okay? So if I want to find the 4th term of X plus Y to the 10th, I'm gonna do my NCR, we're gonna do 10C7, or you could do 10C3. Again, I'll prove to you both of those are the same. Then we have to write our X term, and then we have to write our Y. Now, we just use basic X and Y's right here. Do I need any coefficients in front of those, or are they good as they are? They're good as they are, because there's no coefficients or negatives or anything above. So I'll just write X to the 7th, Y to the 3rd. So all we have to do is remember how to do NCR in our calculator, and we're gonna go find that number. So again, some of you might have to type 10 first and then go find NCR. Does anyone remember where NCR is? Math, go to prob. Good, it's right there. 10C7. And that's 120. And again, I'll do the same thing and do, oh, that's not what I want. I'll do 10C3 to prove that they are the same answer. So you can use the X or the Y, it doesn't matter. So my final answer here is 120, X to the 7th, Y to the 3rd. So I'm just gonna go back up to Pascal's triangle. Remember how a lot of those terms numbers were repeated? Because of how the triangle is formed and because of how the probability works, even the number, like this is the 3rd term and the 4th term, like they have the same coefficient. And that's the same thing. If we were to go all the way down to the 10th term, the 7 and 3 would be like on the same sides. All right, and then that's it for that one. If we have some coefficients like we do in letter B, we're gonna have to do a little bit more work. So why don't can you count out, figure out what my 3rd term is gonna be? Figure out what your NCR is gonna be, and then we'll simplify together.
Why is it, why the 2nd? When you get the 2nd?
The Y increases as we go across the page. And so we started at 0 Ys, and then we went to Y to the 1st, and then now we're at Y to the 2nd. So Y goes up. Also, you can check your work. Remember that those two exponents are supposed to add to the total. So if I have 5 and 2, does 5 plus 2 add to 7? If you have like 5 and 1 or 5 and 3, you might be like, oh, shoot, I messed something up. So that's a good check for you. Okay, help me out, guys. When I do NCR, I'm gonna do what? See what? What was it? I like 7. 7C. 5 or 2. Good. 7C5, 7C2. It doesn't matter to me. Why is it 7? That's the total exponent. That's just in the problem. Sometimes we get confused and we're like, oh my God, I don't know where to look. It's just the number that's in the problem. Okay, now I have to write my 1st term and then my 2nd term. So my 1st term, oop, I didn't mean to do that, sorry. My 1st term is to the 5th power, my 2nd term's to the 2nd power. I only use X and Y's to just kind of make this term very simple, but I've got to remember that my X has a 2 in front and my Y has a negative in front. So when I put this in, I need to remember it's not just X, it's gonna be 2X. And it's not just Y, it's negative Y. Because we're gonna need to do those exponents. Okay. And I got rid of my calculator and I kind of do need it. So I'm gonna do 7C5. So that's 21. I could also do 7C2 and get the same answer. So just proving to you either one works. Everybody good so far? And then I'm gonna do 2 to the 5th and X to the 5th. So when I do 2 to the 5th, if you don't know that off the top of your head, just throw it in your calculator. 2 to the 5th is 32. And then X to the 5th is just X to the 5th. And then negative Y squared is gonna just be positive Y. My last class was kind of panicked that they got these big numbers, but when we multiply 21 and 32 together, you're gonna get a big number. So 21 times 32. And I get 672 x to the fifth y. Oh, y squared. I don't know why I lost my squared, sorry. That's my final answer. We're done a little bit early, but you have 2 problems on your homework. You don't have the whole homework page to do, but the first 2 are just like these. I promise these problems will be on your quiz on Friday. I just don't wanna shove anything else into your heads. We might have a pretty full class tomorrow, but I think that'll be okay. That's a tomorrow problem, right? All right, let me turn this off.